All right, welcome back. We'll get started here. Couple of things. I hope that you had a good, relaxing 4th of July. Hopefully it was relaxing. Hopefully you got to enjoy some time with family maybe. I hope that last week you used that time that we were out of class to work on the visible body stuff. You should be working through again the integument stuff and then the skeletal system. So my plan today is to quickly hit some highlights of stuff that I want to make sure that you have at least encountered in visible body or that you'll have in your notes. Again, when I'm done with this Zoom meeting, I'll get it posted so that everybody has that. And then I'll post the notes as well for, again, it's just an outline of stuff that you should have made, at least at minimum stuff you should have got from visible body. Again, you have a test that will open on Thursday. So on Thursday, we will not have a Zoom meeting. If you have questions and things like that, just reach out by email, but there will not be a Zoom meeting on Thursday. You have an exam. The exam should open at 8 a.m. on Thursday, and you will have till the end of the day on Friday. That would be till midnight on Friday. So it gives you 2 days to complete the exam. And then being that we're right past the halfway point, you can take a breather and maybe have a relaxing weekend before we jump into the finishing stretch. We'll finish up and get into next week with muscles and then the nervous system. But again, you have an exam on Thursday. It will cover those chapters that we outlined for tissues, the integument, and the skeletal system. Tissues, I spent time on going through most of that on the Zoom meetings and whatnot, and then the integument and bones and skeletal system, that is all on visible body. You had practice quizzes on there. There were graded quizzes on there. Again, as a side note, my plan again, in the syllabus, it says that there's 10 quizzes and it will be up to 100 points. If I can give you more than 10, I will count your best 10. That is my goal. Even the early on visible body quiz getting started counts. So again, my point here is I'd like to fit in as many quizzes as possible. If it is a graded quiz, then again, those will count towards your 10. If I can get in 15, that's great, but I will count your 10 best quizzes towards your grade. So that's the goal. I've not moved over the visible body ones yet, but again, you should be able to see your visible body grades. So again, just know they're there. I will get those moved over here into Blackboard as I can. But again, between Blackboard grade book and the visible body grade book, you should know right there what you have and what your grade is, where you currently stand. So again, my plan today, right quick, is go through the notes outline that I have for that. Again, most all of this was in visible body, so that should be pretty straightforward. When I write your exam will be a mix of questions again, just like last time. It will be multiple choice. It will be true, false questions. And again, those questions will come from everything I've given you. The exam questions are written by myself based off the notes I've given you. I will use the test pools for past questions, like the quiz that you had in Blackboard on tissues. I will pull questions from visible body, so a lot of it should seem familiar, all right? Again, when I say this, though, and write the exam, it comes from a test pool, all right? And there's an equal proportion from all of those pools, all right? But each person, essentially, or each student technically gets a unique exam. One's not harder than another. It's just you'll have a mix of question types that'll all come from stuff I think is fair game. So with that being said, if we can hold questions until we get to the end of this outline, unless there's something in the outline that's not clear, lecture notes I'm about to go through, jump in then. Otherwise, if you have questions regarding the upcoming exam or things like that, I'll finish up the Zoom meeting and I'll save time for questions review if need be at the end of this. All right. Sorry, I'm trying to multitask, getting people admitted and whatnot. But all right, with that being said, this past week, essentially you wandered through the integumentary system. That was pretty straightforward on visible body, I think. all the parts of the integument and the function of your skin and whatnot. Where I want to spend today is throwing up what I want you to know, at least or have in your notes, for the skeletal system, bones, and joints. Technically today, if you look back at the syllabus, was really to wander through joints. I think it's one of the trickier or more confusing thing about the body. So I kind of want to hit some highlights on that. But with that being said, let me see if I can share the screen for the notes and we'll work through that. All right. So again, when we think about the systems, what we've done is we wrapped up tissues of the body. Those tissues then get organized into organs and organ systems. And the first organ system we did is the integumentary system. That again is one you went through on visible body. That's the structure of the skin and glands and whatnot that make up that organ system. After doing that, then we wandered into the skeletal system. When we think about your skeletal system, that skeletal system includes basically all of the bones of the body, any of the cartilages that are there between the bones or even within the bones, any of the ligaments that attach a bone to another bone, and all the other supporting connective tissue and whatnot. So your skeletal system includes more than just the bones. It's all the supporting structures and whatnot, whether that's a joint that provides support or has some function, or whether that's a ligament or some other connective tissue that you find. When we talk about the study of bones, osteo means bone. That word should already sound familiar back when we did osteocytes and osteoblast. Osteology, the study of bones. Again, I think most of this should be straightforward. Visible body then worked through the functions of the skeletal system support, right? When we talk about that, your bones are the major supporting tissues of the body. It holds you up. Muscles attached to those bones. It allows for movement. It supports your body. It protects you. All right. Talk about protection. All right. Your heart and lungs and all of that are protected by the rib cage. Your spinal cord protected by the vertebra. Your brain protected by the skull. All right. So it provides an awful lot of protection. In addition to that, there is movement. All right. I already mentioned that. The bones themselves move because a muscle attaches to a bone by a tendon. Now, that's something students mess up sometimes, so just let me highlight that. All right. When you have a bone is attached to another bone via a ligament. So bones attach to bones via ligaments. When we talk about movement of the body, you have a bone on one part. Think about your arm where it flexes at the elbow or bends at the elbow. When you have a bone, there is a muscle over here on this bone. All right. Think about it like your arm, your biceps. And that bone then, or that muscle ends, and the muscle has a tendon that attaches to the bone, so that when a muscle contracts, it pulls the tendon that pulls the bone. That is different than a ligament. Do not confuse the two. Bones connect to bones via ligaments. Muscles attach to bone by a tendon. That's where you get movement. All right, in addition to that, we have hematopoiesis. We already introduced that. It may sound familiar, hematopoietic stem cell production. That was back when we introduced the tissue. So the site of blood cell formation, hematopoiesis. Your blood cells are basically made in your bone marrow, and your bone marrow is in the cavity of your bones. So the process of hematopoiesis, blood cell production. And then there's mineral storage. Again, your bones are made of minerals, mainly calcium and phosphates. It can store those, and if you have a shortage of those, sometimes you'll leach them out of your bones. So it serves as a purpose for mineral storage. All right. Visible body did a really nice job organizing your body into the two main sections. It talked about specifically the axial skeleton and all of those bones and structures that are found in the axial skeleton. When we say the axial, we think of our main trunk. That's your head, your rib cage and vertebra down through the sacrum and coccyx. All right, visible body. Also talk about the appendicular skeleton. This, for the most part, is what we think of all the appendages, the limbs of the body. All right, your clavicle, scapula, the arm, being the humerus, radius, ulna, digits of the hand, and whatnot. Same is true of the legs. All right, as a note, right quick, please know that the question I've asked before in the past, this is a coxal bone. This is a coxal bone. So your coxal bone is part of the appendicular skeleton. You also have your sacrum and coccyx. Note that the sacrum and the coccyx are part of the axial skeleton. When we say the pelvis or pelvic girdle, that pelvic girdle consists of bones that are part of both the axial and appendicular. It's not a tricky question, it's a specific question, right? So back to that real quick. As a side note as well, as an adult, you have somewhere around 206 bones in the human body. As an infant, because some of those bones have not fused together, you have somewhere around 270 bones. So adult, roughly, this is an approximation, versus what you had at birth prior to the fusion of some of your bones. There are two main kinds of bone texture. Visible body did this as well. You should be familiar with spongy versus compact bones. That spongy bone, as visible body discussed, is made of little beams. Those little beams are called trabeculae. All right, that spongy and little supporting trabeculae are what make your bones lighter. All right, it provides a space. This is, for the most part, where you find your red bone marrow. And that is where you have the site of blood cell production, that process of hematopoiesis. And I'm going to abbreviate there again because we just covered it. All right, you also have the compact bone. Your compact bone is the hard outer layer. Visible body talked about it. That hard outer layer is covered by one of those supporting connective tissue wrappings. That is called the peri, to surround. Osteum surrounds the bone. Okay. Sorry, I got someone trying to get in. All right. Make sure. Hold on one sec. Okay. So you should also be familiar with the microscopic anatomy of bone. I know visible body did that as well. Talk about essentially what you have is bone cells, we've already learned, are called osteocytes. All right, the building block, the immature one, would be the osteoblasts. All right, bone cells are called osteocytes, and your bone also, as you can see here, has a very nice vascular, so there are blood vessels, and nerve supply. But they are organized into structural units. They're organized into structural units, and that is called a Haversian system or an osteon. And you should be familiar with those structures that make up an osteon. All right, just to hit it very quickly because I think it does it nicely in visible body. What you're looking at here is one osteon. That osteon has a central canal. It is running parallel with the long axis of your bone. In other words, if we think about, say, your big femur, and I took a transverse section through that femur, then what you would see is a bunch of those osteons running through it. And my picture right here, you would have 3 of those. So I'm now looking at each one of those right here in this picture. There's a central canal, and running at right angles to that, there are the perforating or Volkmann's canals. These are the vessels, the nerves, the arteries, the veins, the capillaries that are leading into that hard matrix of the bone so that it can get to then the osteocytes in that bone. All right. Surrounding that central canal, you have rings. You can almost think if you've seen a tree chopped down, a tree stump is made of a bunch of tree rings. Well, those rings in the osteon are called lamellae. All right, sandwiched between the lamellae, you find these hollow cavities, hollow little chambers. Lacuna means chamber. The lacuna are these hollow chambers that you'll see occur between the lamellae. And in those lacuna, that is where an osteocyte lives. So your osteocytes, each lacuna would contain one osteocyte. So there'd be an osteocyte in here, there'd be an osteocyte in here. All right, that's main structures that you find. All right, there's a couple of other small ones. If we look more closely, see, we have to be able to, if this is a hard matrix, lead to each of the lacuna here. So in other words, these have to be interconnected, all of your lacuna. Think of it like a road work, a road system. Our cities are interconnected by interstates and then highways and all this kind of stuff. If we pull into your neighborhood has streets that lead to then your driveway and all that kind of stuff. So if each lacuna is like a little home for an osteocyte, there's something that has to lead to it so it can get these vessels there. That's the job of the canaliculi. They are the minute, the tiny little chambers that are leading to the lacuna where you'd have an osteocyte or leading away from it. So these are all the little road networks that are leading away from where you find an osteocyte and lacuna. So each one of these would have canaliculi, if you would, running out from it so that you are interconnected within here. Okay? Now, if we think about this in a little bit more detail, and I just mentioned over here that you have more than one osteon within your hard bone, well then, if you take circles and you try to sandwich a bunch of circles together, they're not like squares, so there has to be some open space in between them. And so all that open space that you find there in between is called interstitial lamellae. Interstitial, in between the other osteons, and that is interstitial lamellae. It's not empty air pockets, empty spaces. It's filled with calcium and phosphates and supporting tissue. But that area in between the osteon is called an interstitial lamellae. This body also probably went through and talked about the chemical composition of your bone. All right, you have what ends up being the organic versus the inorganic. Your organic is what gives it its flexibility, its tensile strength. So again, it can bend to some degree before it breaks. That accounts for roughly 35-ish% of what your bone mass is, and it includes all of your osteoblasts within that. It includes your osteocytes. That's your bone builders, if you're here, your immature bone. That's the mature bone cells. And it also includes what's called osteoclasts. It turns out you have those things that break your bone apart as well. In other words, you're constantly remodeling your bone. That's an osteoclast. All right. In addition to that, it includes your osteoid. All right. That's part of the ground substance that provides the flexibility. That ground substance being like your collagen fibers All right, so supporting connective tissue. This is different than the inorganic. Your inorganic accounts for 65% of your bone mass. This is what makes your bone hard, and it mainly is calcium and phosphates. Sometimes it talks about those being hydroxy apatites type stuff. All right, so two main chemical compositions of your bone, the organic versus the inorganic. Visible body, then wandered through, talking about ossification and bone growth. Again, when we talk about connective tissue, remember, it all starts as mesenchyme. So the precursor to any of your bone, being that it was a connective tissue, was mesenchyme. All right, you start making your bone, which is the process of bone formation, is called ossification or osteogenesis. That takes place about week 8 of embryonic development. So about 8 weeks after conception, you start forming the bone tissue. All right, and I break that into two types of things. There's what's called ossification, which means we're taking one type of connective tissue membrane and starting to replace it with bone. All right, there's intramembranous. This is what occurs from a fibrous membrane, and it is largely what made your flat bones, like the bones of your skull. Endochondral, chondrous, it's like cartilage. This occurs in a hyaline tissue. It made most of your other bones. So about 90% of your skeleton started off as a hyaline cartilage that then transitioned to bone. All right? That process is under the control of growth hormones. All right? Now, when we talk about bone growth being under hormonal control, there's that which occurs before puberty and that which occurs after puberty. Anything before puberty is via your growth hormones. If it's after puberty, then in addition to growth hormones, androgens start playing a role. That would be the testosterone, all right, is a large hormone, or a main hormone, if you will. Sorry if you hear my dog in the background. There's a main hormone that then takes over and really ramps up bone production. All right. But bone growth after you're born, all right, then occurs in two main types. There is appositional growth. This is how your bones grow in diameter. They increase in thickness. There is interstitial growth. This is how your bones grow longer in length. You notice an awful lot more of an increase in length than you do in thickness. Think about, again, you were born and you were this tall, all right? Your femurs, the radius, the ulna, the humerus, the tibia, fibula, all that you noticed as you grew in length drastically, okay? Visible body should have gone through the main structures of a bone. We've talked about the ends already, all right? The ends of your bone being the epiphyses. There's a proximal epiphyses that's closer to the point of attachment, and a distal epiphyses that's further from the point of attachment. So if you take your, like the head of the humerus, that would be the proximal epiphyses. If you take the end where you find the trochlea and the capitulum, that would be the distal epiphyses. Where you have the shaft, that is the diaphysis. And then it wandered through the structures of where you find the spongy bone, the medullary cavity. There's a periosteum surrounding it. We already mentioned that. Lining the medullary cavity, there's an endosteum. So in addition to having a periosteum on the outside, inside along that medullary cavity, you have an endosteum, one that surrounds and one that's inside. One of the most common injuries that occurs to your bone is a fracture. A bone break is a fracture. It is the most common type of bone injury. And there are two main kinds. There's what's called the spontaneous or pathologic fracture that occurs from like diseases and things like that, or there's traumatic. in a traumatic fracture is generally the result of an accident. You've fallen and you break your hip. You're in a car accident and something gets broken. All right. The traumatic fractures are the most common. All right. And there's different types based off whether it is transverse or linear and things like that. I think Visible Body covered some of the details of that as well. Oops. Upon a bone break, there's repair that occurs. And in general, there are 4 major steps. Some books and things do more, some do less. But again, the difference in this is going to be based off the degree to which your bone is broken. There are 4 main ones. When you break your bone, it bleeds and it hurts. And so one of the first things that occurs is you have a hematoma form. All right, that basically means you're going to try to stop the bleeding and start the repair process. Once that occurs, you create a soft callus. It cleans out debris, anything that's dead, and starts laying down a fibrous network, fibrous tissue to bridge that gap and begin the repair process. All right, once that occurs, you start forming the hard callus. That fibrous tissue is replaced by bone that's hard. And then the final touch is what we could just consider a remodeling. All right. Think of it as like you're building a house. The very remodeling, that end point would be that you're going in and doing the fine touches, the final trim work, the cleanup, if you will. That's the remodeling process. Those are the 4 main steps for a bone repair when you break it. And again, the degree to which that break heals is dependent on how bad the break is. And maybe to the point that you can't even tell the break was there, or it may be so severe that you actually can still tell, or at least see some degree, especially like in an X-ray. All right. Now that covers what, again, I think Visible Body did a nice job of, or any additional stuff that I want you to be familiar with as you get into the test for Thursday, Friday. What we wrap up with is articulations and movements. And if you look at Visible Body, I think if I can do that, hold on a sec. I had it here somewhere, give me a sec. All right, and if we get into the final stretch of Visible Body, then what it did is has a very nice section where it covers essentially the joints. It introduces the joints themselves, and then it talks about the joints of the skull, and then how you classify those different joints. And there's a bunch of sections that it goes through to try to explain the different joints of the body. All right. So you have examples of a bunch of joints and their degree of movement. So what I want to do is also provide a little, gotta get back to it now. Hold on. That's not what I want. Let me just, oh, there it is. What I want to do is sort of take what Visible Body did and organize it. I guess try to highlight a couple things I don't think it does a nice job of organizing. Okay, so when we talk about an articulation simply means a point of attachment. And for the body, that means a joint. And those joints have some degree of movement. So when we classify a joint, we can classify a joint based off its structure. All right, that again is the anatomy of it. And we can classify it based on its function. That's going to be the degree of movement. Structurally, a joint can be made of a fibrous tissue, a cartilaginous tissue, or a synovial tissue. All right, you'll see this as we go along. The fibrous joints of the body and the cartilaginous joints of the body lack a joint cavity. They have no cavity in between those joints. They just have that structure, the fibrous membrane or a cartilage between there. There's not an open cavity. Your synovial joints, on the other hand, have a joint cavity, a pocket, if you will, and that's filled with synovial fluid, right? That helps what it's meant indicate the general type of movement that you're going to have. So when we talk about function, function is the degree of movement. Synarthrotic means no movement. Amphiarthrotic means slight movement. And diarthrotic means fully movable. So we have what it's made of and how it functions. What I've done to provide sort of a background outline, assuming you didn't take notes for visible body in those sections, what I've done then is provided or organized these joints based off their structure, because it's easy to tell what a joint is made of. Sometimes it can be difficult to say the amount of movement. Well, is it supposed to move? Is it not supposed to move? So that gets a little trickier. So what I've done though, is I've taken and I've outlined what it's made of, whether it's a fibrous joint or a cartilaginous joint. You can see there whether or not it lacks a joint cavity. And then synovial joints. All right. What I also did then is provide examples for each type. So a fibrous joint could be a suture, a syndesmosis, or a gomphosis. So all of these that you see now, these three here, are examples of fibrous joints. And I've tried to illustrate, like visible body did, then the degree of movement you find with each one of those. Again, visible body does this and tells you where you find them and gives examples of each one as well. Okay, I've done the same thing for cartilaginous joints. A synchondrosis and a symphysis joint are both examples of cartilaginous joint. We've also then illustrated here the degree of movement for those. Right? A synovial joint is a diarthrotic joint. Synovial joints are always diarthrotic. So synovial joints are always fully movable. This is the one that does have a joint cavity. It has a cavity. It is filled with fluid called synovial fluid. All synovial joints are diarthrotic. Let's go back so that's clear a little bit about what I'm saying. I cannot say, if you look here, all cartilaginous joints are not synarthrotic. It's synchondrosis is synarthrotic, but a symphysis is amphiarthrotic. So I can't make that same type of statement down here when I'm looking at synovial, cartilaginous. Synovial joints are always diarthrotic, and all diarthrotic joints are synovial. That is not true for the others. Okay. I can't remember now, it's been since, but one other thing I want to mention in regards to synovial joints is a process called weeping lubrication. All right. And so what that essentially is trying to explain is when you looked on visible body and it did and covered that point where you have a synovial joint, then one of the things it talked about is that the ends of those joints are covered in articular cartilage or hyaline cartilage. All right. Well, the point I was going to make up or bring up here then is when there is no, so this is our synovial cavity. When there is no pressure on that cavity, much of that synovial fluid is up in that hyaline cartilage. So think about the blue structure I have here like a sponge. If I took this sponge and there was a bunch of liquid here, this is the synovial fluid. If there was a sponge on either side, a lot of that liquid would get absorbed by the sponge. All right? So when there's no pressure on that cavity, a good portion, not all, but there's synovial fluid that is in the articular capsules, articular cartilage on each end of your bone. As pressure increases, take for example, like when you go to take a step and your femur is forced towards your tibia, so your knee joint there, when pressure increases in there, that pressure squeezes that capsule. So think about now like you've taken that sponge and you go and squeeze it. Well, when that increases, that fluid comes out of those capsules, or it weeps out of those capsules to lubricate that area and prevent those bone ends from smashing together. So weeping lubrication is a process by which when pressure increases in a joint, the synovial fluid or some of that synovial fluid is weeped or squeezed out of the articular cartilage. All right, that is the material that highlights what Visible Body did, as well as introduce some of the things that I wanted to make sure you got as you move towards the test that's on Thursday. Again, we will not have a Zoom meeting on Thursday. You will have an exam. I plan to have it open at 8 o'clock. There are 50 questions. Again, they come from a random pool, a mix of stuff that's fair game from anything I've done or we posted in Visible Body. I'll do an even mix of questions across the board or an equal proportion from each of those sections that we covered. But it is a random pool. Each student gets sort of a random test. All right, 50 questions, 2 points each. You'll have an hour for the exam. All right, that should be plenty of time. Again, it doesn't kick you out at the end of the exam, but if you exceed the time limit, I will deduct your points. All right, unless you have a reason to exceed the time limit. All right, with that being said, the exam will open on Thursday. It will close on midnight Friday, so get it completed before then. Gives you a chance over the weekend to maybe do some of your other classwork or to take a break. And when we come back next week, then we'll start the muscular system. As a side note, I am around, I'm here. So again, shoot me an email if you have questions that come up as you're preparing or as you're studying. Otherwise, I'm gonna stop the recording.